Write a polynomial function with a leading coefficient of 1, degree 5, zeros at x equals I, x equals 5 minus I, and passes through the origin. Write the function in factored form, but using only real numbers. We'll write the polynomial in the factored form shown below, where a equals a leading coefficient, which in our case, we know a equals 1. And now let's list all of the zeros. Let's start with the fact that we know the polynomial passes through the origin. That means the origin is an x-intercept of the graph of the polynomial, and therefore x equals 0 is a 0 of the polynomial. So we'll list x equals 0 as a 0. Next, we know x equals I as a 0. Complex zeros always come in complex conjugate pairs, which means if x equals I is a 0, then so is x equals negative I. Similarly, if x equals 5 minus I is a 0, then x equals 5 plus I must be a 0. Notice we have a total of 1, 2, 3, 4, 5 zeros, and because we're looking for a degree 5 polynomial, each of the zeros have multiplicity 1. Following the form for a polynomial below, we have p of x equals a, which is 1, and then we have binomial factors in the form of x minus the 0. We have a factor of x minus 0 because of the 0 x equals 0. We have a factor of x minus I because of the 0 of I. We also have a factor of x minus negative I because of the 0 of negative I. We have a factor of x minus the complex number 5 minus I, and a factor of x minus the complex number 5 plus I. We can leave this in factored form, but we can only use real numbers, and therefore we'll have to determine this product as well as this product. Let's work on this on the side. Let's first determine the product of x minus I, and notice this simplifies to x plus I. I'll go ahead and show all four products, 1, 2, 3, and 4. X times x is x squared, and then we have plus xi, minus xi, and then minus I squared. Simplifying, xi minus xi is 0. We know I squared equals negative 1. We have minus negative 1, which simplifies to plus 1. The product is x squared plus 1. Going back over to the polynomial, we now know p of x equals, we don't need the 1, and x minus 0 is x. We have x times the quantity x squared plus 1. And now we need to determine this last product, which is x minus the complex number 5 minus I times x minus the complex number 5 plus I. So first we have x times x, which is x squared. And then we have x times the opposite of the complex number 5 plus I, which is minus x times the complex number 5 plus I. And then we have minus x times the complex number 5 minus I. And then finally we have plus 5 minus I times 5 plus I. Let's begin to simplify. We have x squared minus 5x minus xi, and then minus 5x plus xi, plus, for this last product, we have four products, 1, 2, 3, and 4. 5 times 5 is 25, giving us plus 25. And then we have plus 5i minus 5i, which is 0. And then finally we have minus I squared. Simplifying, we have x squared minus 5x minus xi minus 5x plus xi. And then for this last product, we have four products, 1, 2, 3, and 4. 5 times 5 is 25, giving us plus 25. And then plus 5i minus 5i, which is 0. And then we have minus I squared. Simplifying, negative xi plus xi is 0. We have x squared minus 10x. And then we have 25 minus I squared, which simplifies to 25 minus negative 1, or 25 plus 1, which is 26. Which means in factored form, the polynomial is x times the quantity x squared plus 1 times the quantity x squared minus 10x plus 26. And we were told we could leave this in factored form. If we wanted expanded form, we'd have to multiply this out. I hope you found this helpful.